and astrophotography at least a little bit, as astrophotography is a huge area where the learning curve is extremely steep and gets really, really technical. And night panoramas are quite familiar and popular now. You can see a lot of Milky Way panoramas in the summer and Orion images and night winter images in the winter season. In all social media and also it's quite really popular, and these images are getting popular as the quality constantly increases. But if you look at these images in screen size, everything looks very, very fine. Here I have some example of a Milky Way image, and it looks very nice on Instagram or Facebook, but it's taken with 6400 ISO, and if you look at it, it's noisy as hell. And usually it's no problem if you have an average DSLR and you scale down the images to Facebook or Instagram size, it's no problem, everything looks fine. But we are not, if you're doing serious panoramic photography, you are not only producing for Facebook or social media or screen size or screen resolution, but you want to zoom in an interactive display down to pixel level, and then it gets serious. There's one big advantage of modern sensors in the last time. These sensors see an incredible amount of light. And former camera sensors have very fast degrading image quality when it gets to high ISO. Think back to, let's say, 5D Mark II, Canon 5D Mark II at 6400 ISO. You have so much noise, you can even distinguish any color information. But this changed, especially with the Sony sensors, which are really night vision devices. And I have prepared one example here. It's a night panorama near Zurich, and with heavy light pollution. And I stood at this point, and the sky, especially at the southern horizon towards the Alps, it's the right part here. This region was absolutely black for the naked eyes. But even in this view, you can see that there is something, and if you do a close-up here, you see a shine above the horizon, above the Alps. These are the lights of Milan, 210 kilometers away. And that is what the camera sees. But you pay for it with a lot of noise, but the noise level gets lower and lower. And especially modern cameras and full-frame cameras have a fairly big pixel pitch. So, like Canon 6D with 6.5 microns. These are 42 square microns, or Sony A7R. On A7S, especially the A7S with only 12 megapixels, there is an 8.32 microns and a pixel area of nearly 70 square microns. So it's nearly double, nearly double of what the 6D sees. And these cameras can deliver amazing quality. When it comes to night photography, we have to deal with EV values. I'm introducing here an absolute calculation for EVs. Usually, some of you know the Sunny F16 rule, and it's a base. Here you have F16, 125th second at 100 ISO, and it is a normalized ISO value of 15. And it is derived from the EV level 0. It's an aperture of f1, a pretty fast lens, 1 second and 100 ISO. And if you want to get the faint light of the Milky Way, you need a normalized EV value at about -7. That means you have an aperture of 2.8, which is a lot of lenses aperture when wide open. an exposure time of 20 seconds, and 6400 ISO. And at these technical parameters, you need to get the Milky Way show up in your images. There's one issue with f2.8. If you shoot especially wide-angle lenses, you need for panoramic photography, you have some image degradation in the corners. It's called astigmatism or coma, and usually a pinpoint sharp star should be a circle, at least a little point, but these are angels, flies, some crosses, some angles or something like that. And this is called coma, so you cannot use a lot of lenses wide open. This is a lens with very low coma, especially when it comes to some lenses popular in astrophotography.